And we can wait just a few more minutes, then we can start. So share my screen here. Okay, so hello everyone. My name is Qisheng Huang. I'm the solution engineer at Qt company, and yeah, responsible for the EMEA region. So welcome to our webinar session. Today, the topic is how to create unified design for MPU and MCU projects with QML. This is a challenging topic, and hopefully it is helpful for you. So before we start, let's try to clarify in this context, the MPU means microprocessors. Normally they are ARM cores, like Cortex A series, A7, A8, A9, and so on, etc. And normally they run on Linux and other operating systems. And MCUs are microcontrollers. If they are ARM cores, they are normally Cortex M cores like M4, M7, M33, and so on. And also the Renesas RH850 is also a microcontroller. And normally they run on bare metal without an operating system or a real-time operating system like FreeRTOS, Zephyr, or Microsoft, and so on. We will have a short poll later. Let's see how many of you have already used Qt, Qt for MCU, or both, or nothing. Let's continue here. There are many scenarios where unified design is very valuable. For example, a company can develop a portfolio of devices across different price points and technologies. That means, like here, you have a high-end device with a higher resolution and sometimes with 3D in the UI that is based on high-performance MPU devices. Then you can have a mid-range device with medium-sized UI based on low-cost MPU or high-performance MCUs. Then you can have also a low-end device which has a much smaller screen based on MCUs. And also you can have a companion app running on the mobile device or web or desktop. So normally you want to retain a unified look and feel for your pixel perfect UI across the entire range of the product. So it is even better that if you can use the same core technology, then you can have a smaller team that knows the that knows how to design those things. Yeah, and also even better that you can even reuse the code across all the devices. Yeah. And another scenario here is that you can have multiple displays in one product. So for example, in a car, you can have a smaller smart knob based on low-cost MCU and an instrument cluster that is maybe running on the multi-core SoC and an IVI running on MPU and or a rear seat entertainment display running also on the MPU. And maybe you can have also a HiDAT display here on the screen. And then you can have also a companion app on mobile devices. Then another scenario here, you can have one or more displays on the multi-core SoC. For example, in the safety critical project, the MPU core is responsible for this MPU core that is responsible for the complicated UI elements and sometimes with 3D elements. And the MCU core here that is used for the safety relevant UI elements, for example, to show the speed here. And even better that you can also use the QSafe renderer to show some warning signals here and to make sure that it's always available. And this is already a demo that we have shown a few years ago in the trade fair that is running on the R-car chip with very powerful MPU core and MCU core. So they are running on different scenarios here. So here you can see the green marked area. It is rendered by the Qt Quick Ultralight or the Qt for MCU. And here the yellow one here, it is rendered by the Qt Quick 3D. And you can see they can combine together. So in all these scenarios or use cases, unified design can be very helpful. You can retain the same look and feel and use the same tool trains and even reuse the code for the projects. Okay, before we continue, let's have a short poll session. Let's see here. Okay. So let's have here a few questions. The first one is, have you already used Qt or Qt for MCUs? And the second one is, if you have, which scenario is most interesting for you? Okay, I see that some of you have also choose other scenarios. If you want, you can also write in the QA. Which one will be more interesting for you for the unified design? Okay, let's give another 20 seconds. Okay, good. Now let's enter the poll first. And we can continue. So next slide. So Qt is very great for the cross-platform development. You can use Qt framework to develop software on desktop, mobile, web application, or MPU and MCU devices. And you can find in our documentation page the list of all those officially supported hardware platforms from different vendors, and also an even a longer list of the so-called tier 3 MCU devices, MCU targets. So that means they are unofficially supported, but someone have already done the job to port the Qt for MCU on those devices. And you can see here from the major vendors like NXP, ST, Renesas, NVIDIA, Qualcomm, TI, and Infineon. We have all those officially supported devices. For the MPU cores, you have the IMX 8, 9 series, and so on. And also here, a lot of devices are already officially supported. And also the MCU cores, like the RT series, STM series, RH850, and also Travel 2 devices here. You can use the Qt Quick or the QML language to implement your UI interface on all those platforms. That means if you choose Qt, you have already a very good position to do unified design across different hardware platforms. However, in reality, it is still very challenging to create such unified design and reuse code across MPU and MCU projects because MPU and MCUs are designed for different purpose. So that means here you can see the comparison of the full Qt framework and the Qt for MCU. With the full Qt framework on MPUs, you want to implement most advanced UI features. There are a lot of Qt libraries are already available you can use, and you can get the full advantage of the operating system. You can use a lot of features from the OS, from the graphic accelerator, and the 3D features, and so on. But on the other side, with MCUs, normally you are very cared about the memory footprint. You want to minimize the size of the target application to achieve the best performance and still to achieve a very beautiful UI design. So here we don't have so many libraries on the Qt for MCU, and the Qt Quick Ultralight that is mainly for the UI design, and the other application logic you can write in C or C++, and based on and the operating system here are either bare metal without any operating system, or here you can have the FreeRTOS, Zephyr, and so on. Yeah. So this is the difference between the MCU and MPU platform. Here is the short list of the differences. You can see here the Qt Quick Ultralight. It is a subset of the Qt Quick. There are already a lot of common QML types, but some are missing in the Qt for MCU. For example, the toolbar is not available, and some other types are also not available. And there are additional properties in the full Qt for Qt Quick. For example, in the rectangle in Qt for MCU, there is no border element or border property. And if you use the list view, then some properties are also not available. For example, the current index or current item. And the Design Studio components, so they are very useful, and it's handy for you to create the components very quickly, like the arc item. Now it is introduced already in the latest Qt for MCU version, but previously it was not available. And in MCU, you have this 2.5D design, but in 4Qt, you have 3D and other shader effects. And also, there are different meta files for MCU and MPU projects. So that means for the MCU projects, they are organized by the CMake file and also the QML project file. For MPU projects, you have the CMake file, but also the CMake commands for those projects are also different. So you cannot directly use the MCU project and for MPU or vice versa. Here in this link, you can find the main differences between MCU and MPU projects. Of course, now the version is now changed. You have to increase that to 2.7. Then you have the latest differences comparison. Yeah, also have to mention here our Qt for MCU teams. They are working very hard on that, so that more and more QML types are now already available in the latest version. So how can we remove the barrier, and how can we maximize the reuse rate? So I give you here a few approaches. The first one is to embed the MCU project into an MPU project. And in this example, this approach, is very useful in some use cases. For example, to run an automotive application on a multi-core platform with both MPU and MCU cores, where the basic features here on this screen here, it is rendered by the MCU project, and you can embed that into the MPU project, and you can see here on the right-hand side is the project structure. And you can see here, normally you have the CMake file, the main QML, and some source code. The content here, you have the normal screenshot, screen UI.qml and other assets, and you have a 3D component, so that will looks like this. And then here you have the embedded MCU project. So here on the frame here, the background here, it is rendered by the MCU project. And here you can see all the elements here. And in the real project, it is an overlap of two projects. So the MCU is running in the background to show here the speed will meter, the other informations here. And later, when the MPU starts, it will start the 3D part. So with this approach, then you can easily embed these two together and see, and you can already check how it looks like when the two overlaps comes to the same screen. So it will ease your design in the development phase. Then we have another approach here is to create the reusable QML components that can be used in both MCU and MPU project. And this is our oven project that is done a few years ago. And you can see here the look and feel on all devices are very similar. You have here a very high-end, very high resolution oven project that is based on MPU, and you have here this is a mid-range MCU, have a little bit smaller screen, and here the very low-end MCU devices, for example, they can run ESP32. But you can see the look and feel is very similar. The buttons here are very similar. However, at that time, there are three separate projects for different hardwares. There are three different teams maintaining those projects, and there are no shared code between them. Now let's try to create reusable QML components that can be shared across MCU and MPU projects. Let's pick the function button here. So this is let's pick this very small example here. Let's see how we can do it. So here you can see a few repositories. You can see here the MCU project and MPU project, they are in different Git repository. And inside that, I have here a base module and another extended module. They are submodules inside those project repositories. In the base module repository, you can create your reusable components like this function button. You can have here the QML files, the image assets files, and the CMake list file that will be later used for MPU project, and the QML project file that will be used for the MCU project. Then in the MCU project, you can directly use this function button, basic, and then you can extend this function button for the MPU project. So in this example, we create this function button ext, so-called extension, and it uses this directly use the basic function button, and you can add here some other features. For example, you can add here a shader effect, that is not available for MCU, but is available for MPU projects. And here the CMake list is again, that is for the MPU project. So let's check the code snippet. In the base module, you have this is the function button.qml in the base module. You have the image, you have the mouse area for the click, and you can even have a animation, how it looks like when it is clicked, and then you can add the text below the button. So this is how it looks like. And in the extended module, we can add a glow effect. So here you can, so you will import the function button and the studio effects to add the glow effect. And then you can put the text overlay on top of the function button. And then it looks like this when the button is clicked. So now let's switch to the Qt Creator. I can show you how the project looks like. Okay. So here, inside here is my MCU project. And you can see here, let's switch to the file system view. One moment. Maybe like this. Yes. So here you can see this is the base module that is actually worked as a sub-module inside the repository. Here have the function button and some other buttons here. Yeah, so this is the function button.qml. And we have the assets for different themes. And this is a QML project file that will be used later for the MCU project. And this is the CMake list file will be used later for the MPU project. Yeah, there are some other modules here. And in the main QML, you have the screen.01. And yeah, here I just created several buttons here. And this is a very small example to show you how the concept works. When we run this, you can see on this side, this is the Qt for MCU project. When you click on it, then there is the animation shows how it flashes, and then you can also switch to the light mode to see how it looks like in the light mode. And we can switch to the MPU project. So in the MPU project here, you can see it includes both base module and the extended module as the sub-module inside the repository. And here in the extended module, in the QML file, it will directly use the function button and add the text overlay with the glow effect. So let's see how it looks like. So it runs. We can put it side by side. And when you click the button, then you can see a small overlay or the glow effect will be activated. It uses also the this one to show the light mode and the dark mode. So these are both from the base module, the switch button. So this is a very small example, just show you the concept, how you can do that in the such way. So later, when you want to update the design, you can just change the design in the base module, and the change will be shared between all the projects. Okay, so okay, before we do the ramp up, I think Bruno, you have raised your hand. Do you want to talk? Hello. Okay. Okay. Now let's. Okay. Someone said want to show slide number 7. Let's go back. Yeah. So the slide number 7 here shows yeah, in the practice when you do the project in different repositories or for different MCU and MPU projects, it is still not so easy to directly reuse the code. And here, yeah, so later the approach there will be shown to help you to try to reuse the code here. Okay, now let's do a quick ramp up. And so for the new projects, it is recommended to start the MCU project first and create those reusable QML components, then extend them for the MPU project so that they can be used later. Because the QL or the Qt for MCU, it is a subset of the 4 Qt. So normally you will not have too many problems when you merge that to the MPU projects. Yeah, so this is easier if you want to have the unified design or to reuse those in different projects. If you already have MPU projects, then you can try it out with Qt for MCUs and try to resolve those errors that is not available for Qt for MCU. And it is still doable, but it will cost you a little bit more time to share those codes between those projects, between the platforms. Yeah. Okay, so now let's have another poll session here. Try here. Okay, here we just have 3 questions. Sorry. Yeah, the first one is when will you consider to use Qt for MCU in your next project? The next one is which Qt for MCU features is most important for you? And third one is how useful do you think that webinar is for you? Okay, let's wait for another 30 seconds. Yes. Okay, so now I think we can add the pool. Yeah. Now we can. Yeah. Thank you very much. So that's all for this webinar. Now we can have the QA session. So someone have asked, yeah, about the recording. Yeah, that will be available later, and all the registered guests, you will get the recording later. Then for the code example available somewhere. Yes, I can share the code project example. I'm not sure how easy that is that to share the project. I think I can also make the project public, and then I can share with you the project structure. Yeah. Another one, could the process of manufacturing MCUs at QTS be covered in the future webinar? Yes, I think we can also do that. Uh, so also there are some improvements in the Q Design Studio, especially for MCU. You can also choose the device. If that is available, that is only for MCU, then you will get some notifications if if those features are only available for MCU or not. Yeah, that is only available for, well, actually vice versa, that is that is available for MCU, and if you get the warning, so those features are only available for MPUs, then you cannot use that in MCUs. So also the team, the development team, they are also working on that to yeah, reduce the problems there, so we can use Q Design Studio more efficiently for MCU projects as well. Could additional information on the process of development? Why don't you use the Design Studio for camera? I've noticed that you use Qt Creator. Yes. So as a software developer, that is true. I use Qt Creator more often, and Qt Design Studio is still very valuable. It is also very useful when we use the Qt Bridge to import the design from the Figma tools, from other design tools into that. And of course, we can still use that. But for the real project later that is deployable on the device, then I use normally the Qt Creator. And also when I add the backend C++ modules, then I have to use the Qt Creator as well. Uh, so also in the MCU and MPU, there are also some other features like the font engine and And the partial frame buffer, for example, these features are not included here, and they are only can be only handled in the CMake file. So that is handled differently in this part. And those reusable components, they are only for the QML components here. Okay. Also, thank you for your attending. Um, how good is the Figma bridge working to import my design and use them as UI based? Well, that's a very good question. I think Figma bridge is very useful, and especially well, maybe for both MPU and MCU projects, they are all useful. They in the Figma bridge, you can also have the options to disable those advanced features that is only available for MPU, and you can export that for either MPU or MCU projects. Of course, later you can use the generated QML files as base of the UI design. And um, if I would do that, then definitely I would not directly use that in the real project, but we'll use that as the basic uh, view and then optimize it in the QML file. Uh, I would like to know about tutorials about utilize MCU projects in Figma to QDS. Yeah, okay, so that's also a good idea, a good question. Um, in our team, our technical artists, they are also working on the design for MCU projects, and this is in Figma. So yeah, we can also show you later in another webinar or some web session or video webinar to show you how it works. Yeah, the workflow itself is very similar. You can directly open the Figma and use the Qt bridge to export the assets into Qt Design Studio, and it will generate the QML files for you. Okay. Out of context question, why is it called Qt? Uh, what does Qt stand for? Oh, so Qt, yeah, that's a very good question. So I think the Qt name is already started maybe 25 years ago or 30 years ago. Uh, I think it's called Qt in some phrase, and when we call it cute, because it sounds more cute. Okay, still have 5 minutes. If you still have other questions. I think in the Zoom, I'm not sure if we it's allowed to let the attendees to talk. Okay, so if you don't have other questions, then we can also end the webinar now. So if there will be future webinars, also welcome to our webinar. And by the way, in the beginning of April, from 9th to 11th of April, we will be also in Nuremberg in the embedded world. So if you also there, and then also welcome to our booth to have direct in-person talk, and we will also be there. Thank you. Then wish you have a nice day, and we can stop the webinar now. Thank you. Bye.